Hi everyone, I hope everybody's doing well. Today we are going to be diving into one of the most exciting frontiers in technology, quantum computing. It might sound like science fiction, but it is very real and quickly becoming a game changer in the world of computing. From solving problems that stump even the fastest supercomputers to transforming fields like cybersecurity and artificial intelligence or AI. Quantum computers are opening up new possibilities. Powered by the strange principles of quantum physics, they operate in ways that defy our everyday logic. Whether you're a tech enthusiast or just curious, get ready to explore how this groundbreaking tech is shaping the future.
So, what exactly is quantum computing? Unlike traditional computers, which rely on bits, simple ones and zeros, to process information, quantum computers use qubits. Qubits are special because they follow the strange but powerful rules of quantum mechanics, thanks to a phenomenon called superposition. A qubit can represent both 1 and 0 at the same time. This allows quantum computers to perform incredibly complex calculations far more efficiently than classical machines. As a result, they are opening new doors in fields like artificial intelligence, cryptography, and material science, solving problems that were once thought impossible for even the most advanced supercomputers.
And that's not all. Qubits can also be entangled, meaning the state of one qubit can instantly affect another, even if they are far apart. Einstein famously called this spooky action at a distance. Together with superposition, entanglement gives quantum computers their real power. While classical computers go through one possibility at a time, quantum computers can explore many at once. This makes them incredibly useful for complex tasks like simulating molecules, optimizing big data, or even breaking encryption. Quantum computers are still developing, but researchers have already shown they can outperform classical ones in specific situations.
Now let's talk about quantum entanglement and how it's one of the most fascinating and puzzling phenomena in physics. This quantum entanglement occurs when two particles become linked in such a way that the state of one instantly determines the state of the other, no matter how far apart they are. This correlation happens with no visible connection and appears to bypass space and time entirely. In some interpretations, it even suggests that an effect could occur before its cause. Again, an effect could occur before its cause, challenging our basic understanding of time and causality. Entanglement isn't just a theory. It's been proven in experiments and it's key to quantum computing and encryption.
Let's take a closer look under the hood. Quantum computers don't use regular logic gates like AND or OR. Instead, they use quantum gates, tools that control and change qubits using operations like Hadamard, Pauli X, and CNOT. These gates let qubits interact in ways that create powerful patterns of computation. This is what gives quantum computers their potential for massive speedups. But there is a trade-off. Qubits are extremely sensitive. Even small changes in the environment can cause errors. That's why building reliable error-resistant quantum systems is one of the biggest challenges today, and also why major tech companies are all in.
That's why companies like IBM, Google, and D-Wave are working hard to build quantum computers that can fix their own errors. Right now, we're still in the early days, kind of like the vacuum tube era of classical computers. But things are moving quickly. So, why should you care? Because quantum computing could change everything. It could break current encryption methods, help discover new medicines faster, and take machine learning to a whole new level. Even though it's still developing, the potential is huge. And it's not just for scientists. This technology could shape the future for all of us.
Now, let's take cryptography for example. Today's encryption methods, like RSA, protect everything from online banking to government data. But quantum computers could break RSA by solving complex math problems in a matter of seconds. Problems that would take classical computers years. That's why there's so much investment in quantum research. IBM's quantum network now has over 100 partners, including universities and Fortune 500 companies. Google claimed quantum supremacy in the year 2019 by solving a problem that no classical computer could handle. And Microsoft is working on a new kind of stable qubit, something called a topological qubit, to push this field even further.
Access to quantum computing isn't just for researchers in labs anymore. Thanks to platforms like IBM's Qiskit, anyone can experiment with quantum simulators through the cloud. It's open source and a great way for students and developers, especially computer science majors, to start learning quantum programming. As the technology grows, so does the demand for skilled professionals. New roles are emerging: quantum algorithm developers, quantum hardware engineers, and researchers are just the beginning. The job market is already expanding, and getting involved now means being at the forefront of a field that's shaping the future of computing.
Shor's method is a breakthrough. It can break down large numbers way faster than regular computers, which is a big deal for encryption, especially RSA, since it depends on that process being slow. That's why it's exciting, but also a little scary. It means we need new kinds of protection, like quantum safe encryption using lattice based systems. Looking ahead, the future of computing probably won't be fully quantum or classical. It'll be a mix. In the next 10 to 20 years, hybrid computers could solve tough problems in finance, logistics, or climate science faster than we've ever seen.
For future developers, engineers, and researchers, understanding quantum principles today means being ready to shape tomorrow's computing landscape. While classical computers will remain essential, quantum systems are already showing real advantages in complex tasks like optimization, simulation, and cryptography. This isn't a distant future anymore. Quantum technology is being applied right now in real world settings. As the field advances, skills that combine classical and quantum computing will become increasingly valuable, bridging today's technology with tomorrow's powerful tools. Being prepared means staying ahead in a rapidly evolving industry.
Quantum computing may have once sounded like science fiction, but it's rapidly becoming a science fact. What was once theoretical is now showing real world potential in fields like cryptography, chemistry, and AI. As this technology continues to evolve, it's clear that quantum computing is no longer just the future. It's already here. Thanks for watching.